All right, just as a reminder, you've got your homework right here and what will be collected at the end of this week and graded, as well as a chance to give this an assignment, is going to be that number 46. So if you haven't already, print off the notes or get your notebook ready, and let's talk about arithmetic sequences and series. So arithmetic sequences and series, as you might remember, are where consecutive terms have a common difference each time that we go through the sequence. So if we're looking at this first one, 11, then 8, then 5, then 2, usually it's easier to look at this from an example perspective. Here we can see that the common difference each time that we're going down is -3. And so then that common difference then in this case is -3. So using this as an example, let's fill in some of our definitions. So what that means is each time the same number is added or subtracted, we can just say that it's adding a negative when it's that term. So our first term is A, and then A plus that difference, A plus that difference plus that difference, so 2D, and so on would be how we could write our sequence out. If we wanted a formula for the nth term, which you can see we are going to want in just a little bit, the nth term is that first term, which you can add a subscript of 1 to, plus some number of the difference, and that number is always n minus 1. So you'll notice that the first term, there's 0 differences added. Here there's 1 added. Here's 2 added, when in fact it's the third term. So we just take n minus 1. And this is our formula. You can also write it using recursive if you're interested, which would just be that the nth term is equal to the last term plus that common difference. But you're not going to see that as common. I just wanted to review recursive notation. So here, when we're writing the nth term, we're just going to use the formula here, and we're going to say, well, our nth term is equal to the first term plus n minus 1 times the common difference, which is then the first term we see here is 11, so we can just use the sequence given to us, plus n minus 1 is always there, and then the common difference is -3. Now you might just see this written like this. You could also see it in its simplified form with distribution, which would be 14 minus 3n or -3n plus 14. All of these are fine. Just check in the back of the book. You'll want to be able to simplify it, but it's pretty easy algebra. Once you have a formula, you can answer things like what's the 100th term, which would be very annoying to do by hand, but this 100th term just means n equals 100 using the formula above. I'm going to use the simplified one just because it's simpler. So that would be the 100th term, a sub 100, 14 minus 3n, and then as we said, n equals 100. So then the 100th term is 14 minus 300, or -286. So that's the nice thing about having an nth term formula, is you can just plug things in very nicely. You can also use the formula to find things where we're just given 2 of the terms. So here it says the 12th term is 32 and the 5th term is 18. Find the 20th. Now to solve this, I'm going to use the formula same as last time. So we know that the 12th term, so a sub 12, is 32, and plugged into the formula, that's the first term plus 12 minus 1 times the difference, which we don't know yet. And then we know that the 5th term is 18, which is a plus 5 minus 1 times the difference. And we're asked to find the 20th term. Now what I'd hope that you'd see here based on last unit is we have a system of equations where our variables are a and d. So if I simplify them, I can solve it like a system. So all I did was simplify what's in the parentheses here, and I'm going to cancel out a first since they have the same coefficient, so I will subtract everything, and I end up with 14 is equal to 7D, which tells me that 2 is our common difference here. And if I plug that back into the formula, or one of the equations, 18 equals A plus 4 times that common difference 2, we then get A is equal to 10. So now we know our first term, and we know our common difference, and we've got our formula to find the 20th term. So here we have our first term 10 and our common difference 2 plugged in. And since we want to find the 20th term, we're just going to plug in 20 for n. So 10 plus 20 minus 1 times 2, which is 10 plus 19 times 2, 10 plus 38. So our 20th term is 48. So a little bit of tie-in with our system of equations from last chapter. Let's talk about series. Now, an arithmetic series is where you add up an arithmetic sequence. So we're going to use our sigma notation with then our formula for an arithmetic series. And as we've been starting traditionally, we're going to start at n equals 1, and then the upper bound would be some number out to n. Now, if you're interested in how we can find the formula for this, I strongly encourage you to look at the guided notes complete version that I've put up. I just don't want this video to be 30 minutes long. So there is absolutely a formula for this summation depending on whatever this top number is. Usually we'd call it that top number being n. And it's based to start with on the formula for these terms all added together. Again, if you're interested in how these formulas are derived, I strongly encourage you to look at the guided notes. But for here, the sum of all those numbers is n times n plus 1 over 2, which helps us figure out this formula, which has two different ways that it can be written. The first of which would be A times n plus the difference, parentheses, n times n minus 1 over 2. So you can see that that uses the formula here pretty well. If you see something like what we see in number 4, I'm just going to skip and come back really quick, where we just have a list of numbers out to our final number, you can also use the formula n times the first term in your list plus the last term in your list all over 2. So these are the two formulas. This is the one I recommend if you have something that looks like this. And then this is the one I'm going to recommend if you have something that what we see in number 4, where we just have the list all written out. So here we have our first term, 3. We have our last term, our a sub n, and we can look at the numbers 3, 7, 11, 15, and we can see that our common difference here is positive 4. So if I'm looking at this formula here, the only variable that I'm missing is our n value. And I'm going to find that using our initial arithmetic formula right there. So what we know is that the nth term here is 39. And we know our first term is 3 plus n minus 1, because that's the variable we don't know, that's the one we want. And our common difference is 4. So this is how I'm going to solve. I'm going to distribute and simplify, which gives us 3 plus 4n minus 4, which is 4n minus 1 equals 39. Add 1 to both sides, divide, and we see that we have 10 terms. Our n is 10. If you wanted to write out all those terms to see, that would work, but that just takes a lot more time. Now that I know what n is, I can plug it into our formula, and I know that this series, this sum, is 10 times the first term, 3, plus the last term, 39, over 2, which is then 10 times 42 over 2, which equals 210. If you have any questions, please let me know in the comments, by email, or on Zoom. I'll talk to you all later. Bye.